Hi folks, today we are taking a look at hypothesis tests and how we make hypotheses for hypothesis tests. All right, so what's a significance or hypothesis test? So those kind of are used interchangeably, significance tests, and I have hypothesis tests. I usually use hypothesis tests or HT, but significance tests and hypothesis tests do mean the same thing. All right, so the definition is some sort of formal procedure for using observed data to decide between two competing claims. And these two claims are called hypotheses, the plural of hypothesis. All right, these claims are always statements about a parameter, like the population proportion P or the population mean mu. All right, so we're always talking about P or mu, not P hat or X bar. All right, so we're not working with those. All right, the problems will involve those, but our claims, our hypotheses will always be with one of these two guys. All right, so here's an example. Mr. Robeson claims that over his lifetime, he makes 80% of his shots, it should be shots, not shoots, shots, there we go, in trash-get-ball. So remember, trash-get-ball is when we play basketball in class with the garbage can against the wall and we shoot tennis balls in there. I'm quite good. It's like my calling in life. All right, so my claim is that my proportion, my lifetime proportion, my true proportion P is equal to 80%. That is my claim. All right, how would we test this? Well, we would take a sample. All right, we couldn't go back and measure everything I've always done, but we can take a sample of some particular size that's large enough and see if it matches. All right, now chances are, even if I am really good and get very close to 80%, I won't hit exactly 80%. Like maybe I'd hit 79%, or maybe I'd hit 82%. The question then becomes, at what point do we reject my claim and say that the true proportion is something else? All right, would it be 75%? What about 60%? What if I took like 100 shots and I only made 50 of them? Would you reject it then? Seems like that might be a good idea to reject. All right, but that's basically the idea behind this hypothesis test is we have this claim and we're going to try and we're going to take a sample, and if the sample ends up being far enough away from this claim that we start with, what's called our null hypothesis, which we sometimes write as H sub 0, if it's far enough away from this, then we'll say, you know what, he's probably not right about this 80% thing, and we have evidence that it's different from 80%. Significantly different. Not just a little bit different, but significantly different. All right, so we have two types of hypothesis. The first one we call our null hypothesis, which is H sub 0. That is the number 0, capital H. It's the claim that we weigh evidence against. It's what we start out believing. So we were told I make 80%, that was our starting belief. The alternative hypothesis, H with a little a, we can do lowercase a or capital A. I usually use lowercase, but capital A is not wrong either. The claim that we are trying to find evidence for our test. All right, so we're trying to find evidence that it's different from 80% or greater than 80% or less than 80%. So the null hypothesis will always be equal. For our class purposes, we can always use the equal sign, and we can just write it like this. All right, P equals something, or if we're working with mean, it would be mu equals something. Like, I don't know, 32. All right, we can put units on here too. I'm thinking about the football problem we had from the last section on the test. All right, so the second type is our alternative hypothesis. And there's two ways or two things that can happen with our alternative hypothesis. Either it can be a one-sided claim, and one-sided means that the P is going to be greater than something or less than something, and that something is your same thing as your null. Or we can say that our mean is, greater than the 32 yards, or our mean is less than the 32 yards. All right, so we're looking for the words more or less in our sentence or in our problem somewhere that tells us this is our alternative hypothesis. All right, the other thing we could look for is it just difference? All right, so is it different from what we were told? So we say our alternative hypothesis, H sub A, is that our true parameter P is not equal to 0.8. or 0.80%, or we could say our true mean is not equal to 32. All right, so we're looking for the word different or differs or has changed. All right, so back to my example, what was the null hypothesis? And if we believe the true value to be less, what is the alternative hypothesis? So the null hypothesis is that the true value is 80%. So we could say 0.80, or we could write out 80%. That's fine. The alternative hypothesis is that P, we think it's going to be less than that, is less than 0.80. Now, we're missing something here. We've never said what P stands for, so we need to say that. P is the true proportion of, let's see, we're talking about trashketball, Trashket, ball shots Mr. Robeson makes. There we go. So we have defined our P, and this is trashketball. Trash, like the trash can, trash kit. All right, so another example. At the Hawaii Pineapple Company, managers are interested in the size of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested from one large field was 31 ounces. All right, so it looks like we're talking about mean, and we got 31 ounces. A different irrigation system was installed in this field after the growing season. Managers wonder if this change will cause the mean weight of pineapples grown in the field this year to be different. State the appropriate hypotheses for performing a significance test. Be sure to define what our parameter of interest is. So our parameter, we're talking about mean, and we say it's the true mean weight. Now let's see, what is it? The true mean weight of managers when it causes the mean weight of pineapples grown in this field. So true mean weight of pineapples grown in this field. Left off an L there. There we go. So now we want to start with our null hypothesis, H0, null, starting hypothesis, and we want to come up with what our alternative is. So our null is always equal. We're talking about the mean, so it's the mean is equal, and we're going to say it's equal to what it was last time, 31 ounces. If you want to put units here, that's fine. Mean weight of pineapples grown in the field in ounces. We can put units here too. There we go. And the alternative is we're asking, is it different? So is the mean no longer equal to 31 ounces? All right, has the water system gotten that we're growing larger pineapples, or has it changed so that we're growing smaller pineapples? So it just needs to be different, significantly different. So like if it came out to like 31.1 ounces, I'm not sure if that's significantly different or not. But if it came out to like 35 ounces, that seems like that might be different, significantly different. All right, another example. Mr. Robeson says he can predict the winner of any football game with 75% accuracy. It worked this weekend. There were 4 games. I had 3 of them right. You don't believe him. Well, probably for good reason. You believe the true proportion to be less than 75%. What is the alternative hypothesis? All right, so always start with just, we got to say what P is, and then we've got our null hypothesis, and then we've got our alternative. So P would be the true proportion, or the population proportion, of NFL games Mr. Robeson, let's see, what did we say? Predicts the winner correctly, or correctly predicts the winner. Yeah. The Saints let me down this weekend. That was it. That's when I lost, the Buccaneers over the Saints. All right, so we're going to start off with the null hypothesis. Even if we don't have much evidence, we're still starting off with that. It's 75%. P equals 75. Our alternative then is we got to think, is it greater than, less than, or not equal to? When we go back and we read, you believe that the true proportion to be less than 75. So we say less than 75. So we get that our alternative is less than 75. There it is. All right, so that's how we make hypotheses for hypothesis tests. The next one, we'll go over how to interpret the results, and then we'll go over how to, in the next section, we'll go over how to really do them. But interpreting results next.